Hey everyone, I'm Michelle. I'm here to talk to you about our glow discharge plasmas lab, and I'm going to give you some background on plasmas. They can be found in the sun and any star in our universe and lightning. And they can also be found in something called the northern lights, which you can see if you visit Iceland at the right time of the year. There's also so many applications in technology that we use here, including neon lights, plasma TVs, and even medical equipment. So now that you have some background, let's give you a tour of our lab.
And this is our project room. So each student, there's 3 students in here right now. Each student has their own setup, where we all have our own vacuum pumps, our own power supplies, and then we manufacture our glow discharge tubes, such as these big ones, and then we manufacture these smaller ones. And they all work in the same way. We have a gas chamber with some outlet where we pump out some air to get it to really low pressures, and we apply really high voltage to these electrodes to make the gas break down into a plasma. We have some where we coil some wire to induce an axial magnetic field and study how it affects the plasma. And then in some we use circle magnets. And then to drive these, we use capacitors, and we measure the voltage across them using a voltage divider. Now basically how it breaks down is when we apply the large voltage, it makes the electrons and the nuclei of the atoms and molecules inside the gas to rip apart and become ionized. And this ionized soup of ions and electrons is what a plasma is.
This is our power supply, and I have been pumping out the gas inside of this tube, so it's in a really low pressure environment. And the power supply applies about 2000 volts across the 2 electrodes here, which causes a gas breakdown. And to make it flash with the capacitors, to make an RC circuit and turn the system into a oscillator. And as you can see, if I disconnect the capacitor here, it will just keep glowing, but we'll not be able to see the flashing. And with this capacitor, it helps us to take measurements of the breakdown voltage at each peak of the flash. Here's the example of our Paschen curve. We use software to plot the breakdown voltage against the pressure times length. And our results shows that at low pressure range, as the pressure increase, the voltage would drops down, and there exists a minimum point. After this point, the breakdown voltage would increase again as the pressure increase. And our studies focus on the effects of the magnetic field on the Paschen curve, and we make our tubes with these wires to apply different B field to the tube.
So this is where we do our machining, and we cut aluminum and glass. This is a test tube that we cut, and use these to make every tube that we've created. For example, this was created by Juan, and these are more test tubes that we cut. I'm Michelle.
I'm Juan.
I'm Auguste.
And this has been our lab.